This is Numbers with Nicole. We're going to continue our lesson here on inscribed angles. I'm going to do a few more examples on some problems of how we could have these inscribed angles given to us. So we want to find the measure for model number 3 of arc CAB in degrees, and they gave us this inscribed angle CAB. Right, so I want to find the intercepted arc CAB and how many degrees that is, and I am given an inscribed angle of 55 degrees. So the intercepted arc BC of this angle would be double that angle A. We know the measure of angle CAB is going to be half of the measure of the intercepted arc CB. So 55 degrees is half of what arc measure? And so we would double both sides. The opposite of multiplying by half is multiplying by 2. And so we would get an arc measure of 110 degrees for BC. But it didn't ask me for BC. It asked me for the measure of arc CAB. So now if you notice, arc CB and arc CAB form a circle. So in order to get the measure of arc CAB, we're going to subtract from 360 the number of degrees of an arc in a full circle. And so 360 minus 110 is 250 degrees. And it looks like it's more than half a circle, so that makes sense that it would be bigger than 180 for model number 3. So for model number 4, they want us to find the measure of arc AC. So again, how many degrees fits in this arc here? That's what we're looking for. And we are given a diameter AOB. I know it's a diameter because it has 2 endpoints on the circle and it passes through the center O. So from our lessons before, when we talked about central angles, we talked about diameters dividing the circle in half, so it creates a semicircle. So I know that all of this side is going to be 180 degrees, which means that all of this other side, ACB altogether, would also be 180 degrees. So now I have a inscribed angle of 30. And so if I were to double that to get the arc measure, so the measure of angle A, the inscribed angle would be half the measure of the intercepted arc. And so again, we have the angle measure. So to solve for that intercepted arc BC, we would multiply both sides by 2, giving us 60 degrees for the measure of arc BC. Okay, so I know the total has to be 180. I already have 60, leaving me with the measure of arc AC left, which would be 120 degrees. Right? Remember, these two pieces have to add to 180, or half a circle. So for model number 5, we have 2 options here. I believe this is how this works out. I guess we'll find out. So we do have a triangle inscribed in a circle, and we know that the angles in a triangle have to sum to 180. So we can use that to get the inscribed angle B, and then we can double that angle B to get arc DC. Because we know the measure of angle B is 1/2 the measure of intercepted arc DC. So we want to know how many degrees is in this arc here. So again, to find angle B, I could do 180 minus 49 minus 70. And that would give me the inscribed angle at angle B, so 61. And that would be half of whatever the measure of arc DC would be. So I know that, again, to solve for that, I would multiply both sides by 2. So that would be 122 degrees for the measure of arc DC. So there's another way that you could do this as well if you wanted to use the intercepted arcs instead. So we could double the 49 and we would get 98 degrees for arc BC. We could double the 70, and so that intercepted arc would be 140 degrees. And so we could do 360 minus 140 minus 98, and hopefully we also get 122. And then that would also give us the same answer. So you can either use the inscribed angles and then make that into the arc measure, or you can take the inscribed angles given to you in the triangle and then make those into the arc measures. Either way is fine. Just remember that you're working with circles, and circles in degrees in terms of how much arc they have is 360 degrees. The arc of a circle is 360. So here, our last example, we're going to find the measure of angle B. So that means if I'm thinking about in terms of arcs, I can't think about a quadrilateral because I only have one angle, and I would need 3 to find that using just the angles inside the shape. So we're going to have to do this in terms of arcs. All right, so to find angle B intersects arc ADC. So angle B will be 1/2 the measure of arc ADC, right? The intercepted arc. Okay, so how do I figure that out? All they gave me was this inscribed angle, which has an intercepted arc. That would be double of the 120. So the measure of angle ADC would be 1/2 of the intercepted arc ABC. And our intercepted arc will be double the angle, because in order to get that amount, 1/2 of this amount must be double. So we get 240 degrees equals the measure of arc ABC, right? 240. All right, so how does that help me then? That helps me because I know that the other part of the circle, the rest of the circle in green, would be 360 minus that 240, which leaves us with 120 for the arc measure. And so we know that angle B is going to be 1/2 that. So the measure of angle B will be 60 degrees. And remember, we can think about this as both of these arcs make a full circle, meaning the sum of these two angles should be 180. 1/2 of 360, their sum of the arc measures. 1/2 of 360 is 180. So angle D plus angle B should be 180. So 180 minus 120 is also 60. So 2 ways to think about this example.